Is it possible we're living in Earth's second attempt at life? In the pale warmth of a younger sun, long before anything with eyes could witness it, the Earth held its first breath. The oceans had just begun to settle into the basins of a cooling world, and somewhere in that vast mineral silence, something stirred that was neither rock nor water, but a quiet trembling between the two. It was not alive, not yet, but it was leaning in that direction, the way a single note leans toward becoming a song. The dawn light fell on water that had never known reflection, on stone that had never known moss, on a world still learning what it might become. 4 billion years have passed since that leaning. Mountains have risen and worn down to sand, their sediments carried by rivers to seas that no longer exist. Continents have wandered like slow clouds across the surface of the globe, colliding and separating in a rhythm too slow for any single lifetime to perceive. And through all of it, life has persisted, adapted, diversified into forms so varied that the mind struggles to hold them all at once. We are here now, breathing, wondering, asking questions that echo back through all that accumulated time. But beneath our wondering lies a quieter question, one that the earth itself cannot answer. What if this is not the first time? What if, somewhere in the deep archive of stone and ash, there was another beginning, another attempt at becoming, another world of living things that rose and then fell silent, leaving behind only the faintest chemical whispers for us to puzzle over in the amber light of late evening? What if we are the second draft of a story that was written once before, in a language we have almost entirely forgotten? The thought arrives softly, without alarm, settling like dust in the corners of an old room that has been closed for ages beyond counting. Everything waits. It does not diminish what we are. If anything, it deepens the mystery of our presence, this unlikely continuity of carbon and water and warmth that has carried forward through cataclysm and quiet alike, through ice and fire and the slow cooling of stars. We are here, now, in this particular fold of time, and the question is not whether we matter, but how many times the earth has tried to make something that could ask such a question at all. The planet has been patient, has been generous with its experiments, has offered up its heat and its water and its endless cycling of elements to whatever might arise from the mixing. Tonight, we drift backward through the ages, past the great extinctions and the flowering of forests, past the first fish and the first cell, into a time when the planet was young and still learning what it could become. We go gently, without hurry, following the faint traces of what might have been and what might have come before. The dawn that greeted those earliest oceans is long gone now, replaced by countless other dawns, each one slightly different from the last. But its light still lingers in the questions we carry, in the wondering that keeps us awake, and also, eventually, guides us toward sleep. And somewhere in the silence, the earth keeps its oldest secrets close. The earth formed roughly 4.5 billion years ago, coalescing from the dust and debris that circled a newborn sun. In those earliest epochs, the planet was a molten sphere, too hot for water to pool on its surface, too violent for anything resembling life to take hold. Geologists call this the Hadean Eon, named for the Greek underworld, and for good reason. The young Earth was a realm of constant bombardment, as asteroids and comets rained down from the dark spaces between planets, delivering water and organic molecules, but also destruction, on a scale difficult to comprehend. Each impact released enough energy to melt rock, to vaporize oceans, to reset whatever fragile chemistry might have been gathering in the shadows of cooling stone. And yet, evidence suggests that life appeared remarkably early. Some researchers propose that the first living cells may have emerged as far back as 4 billion years ago, only a few 100 million years after the planet itself had cooled enough to hold liquid water. Carbon isotope signatures found in ancient rocks from Greenland and northern Canada hint at biological processes operating in those deep times, though the evidence remains fragmentary. worn by the immense pressures and temperatures that have reshaped every surface since. These isotopic traces are like handwriting on a page that has been erased and rewritten many times, faint but still legible to those who know how to read them. The morning light strengthens. Most geologists agree that Earth's earliest crust has been almost entirely recycled through the process of plate tectonics. The rocks that existed 4 billion years ago have been subducted, melted, reformed, and buried beneath younger layers so many times that direct evidence of what lived then, if anything, is extraordinarily rare. We are left with chemical traces, isotopic ratios, the ghostly imprints of processes that no longer exist in quite the same form. Reading them is less like reading a book and more like listening to an echo in a canyon that has changed shape since the original sound was made. The canyon walls have shifted, the air has warmed and cooled, and yet something of the original voice persists, if only we listen carefully enough. Scientists believe that life, once it began, may not have proceeded smoothly forward. The Hadean bombardment that shaped the early Earth included impacts so massive that they could have sterilized the surface entirely, boiling away the oceans and resetting any biological progress that had been made. Some studies propose that life may have originated multiple times during this period, rising in brief windows of calm only to be extinguished when the next great collision arrived. Each beginning would have been erased, leaving no descendants, no record, only the same chemical building blocks scattered across a renewed and empty world, waiting patiently to try again. The sun climbs higher. By around 3.8 billion years ago, the period of heavy bombardment appears to have subsided. The late heavy bombardment, as it is sometimes called, gave way to a more stable environment, one where oceans could persist and the chemical reactions that support life could proceed without constant interruption. It is from this era that we find the oldest unambiguous evidence of life, the stromatolites, layered structures built by communities of microorganisms that left their shapes pressed into stone. These earliest fossils appear in rocks from Australia and South Africa, testifying to a world already inhabited by simple, single-celled life that had learned to capture energy from sunlight and leave its patient mark on the geological record. But what came before the stromatolites remains uncertain. The gap between the formation of the Earth and the first clear fossils is vast, nearly 1 billion years, and within that darkness many things may have happened that left no trace. Some researchers propose that life may have arisen in deep-sea hydrothermal vents, where hot, mineral-rich water meets the cold ocean, providing energy and chemical gradients that could drive the formation of organic molecules. Others suggest that life began in warm, shallow pools, where the concentration of organic compounds could reach levels sufficient for self-replicating chemistry to emerge. Still others look to the spaces between mineral grains, to the surfaces of clay particles, to the membranes of tiny vesicles that may have formed spontaneously in the ancient seas. What remains constant across these hypotheses is the recognition that the early Earth was a place of profound transformation. The atmosphere contained almost no oxygen, the sun was dimmer than it is today, and the conditions that we associate with life were absent. Whatever arose in that strange environment would have been different from anything we know, adapted to a world that no longer exists, drawing energy from chemical reactions that would be impossible in the oxygen-rich atmosphere we now breathe. These earliest organisms, if they existed, would have been at home in an alien world, a world we can only reconstruct through careful inference and patient imagination. The noon light holds steady over ancient water, and here, at the edge of what the evidence can show, the questions begin to multiply. If life arose once, could it have arisen twice? If it was extinguished, could it have begun again, drawing on the same chemical soup that had produced it the first time? The geologic record offers no definitive answers, only the slow accumulation of clues, each one pointing toward a past more complex and more uncertain than we once imagined. The story is not a straight line but a branching tree, and some of those branches may have been pruned long before they could bear fruit or cast their seeds upon the wind. What if there was a first life, now entirely forgotten? Most biologists agree that all life on Earth today shares a common ancestor, a single lineage that has branched and diversified over billions of years into the vast tree of life we now observe. The evidence for this is written into our cells in the shared molecular machinery that translates genetic information into proteins, in the universal genetic code that operates in bacteria and blue whales alike, in the fundamental chemistry of ATP and DNA that underlies every living process we have ever studied. We are, at the deepest level, one family, descended from a single origin that occurred somewhere in the mists of the early Archean eon. But this does not preclude the possibility that other families once existed. Some studies propose that life may have arisen independently more than once on the early Earth, giving rise to separate lineages that coexisted for a time before one, our ancestor, outcompeted or absorbed the others. If this happened, the evidence would be extraordinarily difficult to find. A lineage that left no descendants would leave only chemical traces, and those traces would be nearly impossible to distinguish from the chemistry of non-living processes or from the signatures of our own ancestral line, now ubiquitous across the planet. The afternoon light softens. Some researchers have searched for what they call a shadow biosphere, a second tree of life that might still exist today, hidden among the uncountable microbes that inhabit every corner of the planet. The idea is speculative, and no evidence for such a biosphere has yet been found despite careful searching. But the search itself reveals how little we know about the full diversity of life, even now, even after centuries of careful study. The vast majority of microbial species have never been cultured in a laboratory, never been sequenced, never been named. In that unseen multitude, almost anything might be hiding, including perhaps the descendants of a separate origin that has persisted quietly alongside our own. Beyond what the data can show, there is room for contemplation. Perhaps the Earth was learning, in those earliest epochs, how to sustain the delicate chemistry of life. Perhaps there were false starts, experiments that flickered into being and then faded, leaving behind only the faintest residue in the rock, a smudge of carbon that could be interpreted many ways by those who study it today. The planet, in this imagining, was not a passive stage, but an active participant, its volcanic breath and shifting crust creating and destroying the conditions for life in a slow, iterative rhythm that spanned hundreds of millions of years of patient rehearsal. It may be more honest to imagine that we do not know how many times life began. The question of origins is not a single question, but a series of nested uncertainties, each one opening onto another like chambers in a cave that extends beyond the reach of any lamp. What we call life is itself a category that blurs at the edges, where chemistry becomes biology and simplicity gives way to complexity. The boundary may have been crossed more than once, in more than one way, by more than one traveler, each finding a slightly different path through the wilderness of possibility. Time holds still. The same wind that carried the first organic molecules across the surface of the cooling Earth still moves through the atmosphere today, though it carries different passengers now, pollen and spores, and the microscopic debris of a living world grown vast and various. The atoms that make up your body were forged in the hearts of ancient stars, scattered by supernova explosions, gathered into the cloud that became our solar system, and cycled through rock and water and air for billions of years before arriving at this particular moment of awareness. In a very real sense, you are made of the same materials that made whatever came before, the same carbon, the same hydrogen, the same quiet longing toward complexity that seems to be written into the fabric of matter itself. Some scientists believe that the transition from non-life to life may not have been a single, improbable event, but a more gradual process, a spectrum of increasingly lifelike chemistry that eventually crossed an invisible threshold. If this is true, then the question of whether we are living in Earth's second attempt at life becomes even more complex. There may not have been a single first life at all, but rather a series of approximations, each one slightly more alive than the last, until something emerged that could replicate, evolve, and persist through the vicissitudes of a changing world, a world that would test it again and again. The early oceans may have been a kind of laboratory where countless chemical experiments were running simultaneously, most of them leading nowhere, a few of them stumbling toward something new. In this vision, life did not appear suddenly, but accumulated, like sediment settling in still water, layer upon layer of increasing complexity, until the first true cell arose, fragile and improbable, and destined to change everything that would come after it. Dusk settles over the ledger of stone, and even after life began, there were crises that nearly ended it. The great oxidation event, roughly 2.5 billion years ago, filled the atmosphere with oxygen, a gas that was toxic to most of the organisms then living, a poison produced by the very microbes that had learned to harvest sunlight. Evidence suggests that this event caused a mass die-off among the anaerobic microbes that had dominated the early Earth, a catastrophe that reshaped the biosphere entirely and opened new paths for evolution to explore. What emerged afterward was different, adapted to a new chemistry, the ancestor of the oxygen-breathing world we know today. Later still, the snowball. Earth episodes, when ice may have covered the planet from pole to equator, pushed life to the very edge of extinction. Most researchers believe that life survived these frozen ages in refugia, hot springs, and deep-sea vents where warmth persisted despite the cold above. But the margin may have been narrow, a thin line between survival and oblivion, and in some versions of the story, life nearly ended before it had a chance to become anything more than a smear of microbes on an ice-bound rock drifting through the cold of space. Perhaps life has always been a fragile thing, a temporary arrangement of matter and energy that persists only through luck and adaptation and the blind persistence of chemistry doing what chemistry does. And perhaps, somewhere in the unremembered past, there was another arrangement that did not persist, another experiment that ended in silence, leaving behind only the conditions for our ancestors to try again. We cannot know for certain, but we can imagine, and in imagining, we honor whatever came before us. The last light lingers. There is something peaceful in the thought that we might not be the only attempt, that the earth has been generous enough to try more than once, to offer its warmth and its water and its patient chemistry to whatever might arise. If we are the second draft, then we are also the continuation of something that wanted to exist, something that kept reaching toward complexity even when the first reach fell short. The longing that made us may be older than we know, woven into the very fabric of the planet, waiting only for the right conditions to express itself again. When stone forgets its shape, does it still remember heat? The question has no answer, but the asking itself is a kind of prayer, a reaching backward through time toward something that cannot reach back. We are the inheritors of deep time, carrying in our bodies the accumulated wisdom of 4 billion years of trial and error, adaptation and extinction, survival and loss. Every cell in us is a library, and every library holds books that no one will ever read, written in a language that predates language itself, a tongue of chemistry and form and patient becoming. The twilight deepens. To ask whether we are Earth's second attempt at life is not really a question about the past. It is a question about what it means to be here at all, to be this particular arrangement of matter that can look back at its own origins and wonder. The universe is very old, and most of it is empty, cold, silent, a vast expanse of darkness punctuated by points of light. The fact that we exist, that anything exists that can ask questions and feel wonder and lie awake at night thinking about the deep past, is itself a kind of answer to a question that no one asked. We are the universe looking at itself, and what it sees is both familiar and strange, both comforting and unsettling in its improbability. Oceans rose, continents wandered, time kept breathing, and somewhere in all that slow motion, something learned to remember, to anticipate, to hope. We are that something, or one version of it, and the versions that came before, if they existed at all, are part of us now in ways we cannot see. Their failure was our opportunity. Their silence made room for our song. We carry them with us, these possible ancestors, these hypothetical precursors, even though we cannot name them or know their shapes or say with certainty that they ever existed at all. There is humility in not knowing. The same pale warmth that greeted the first stirrings of life still falls on the earth today, though the sun is older now and the planet has changed beyond recognition. The oceans that once covered a molten world now teem with creatures that the early Earth could never have imagined, creatures that swim and crawl and fly and think, creatures that build cities and write symphonies and send spacecraft to other worlds and ask questions about their own origins. We are among them, the ones who can look up at the stars and know that we are made of the same stuff, the ones who can trace our lineage back through the ages and feel both small and impossibly lucky. If there was a first life, it is gone now, dissolved back into the chemistry from which it arose, its molecules recycled into new forms, its patterns lost in the great mixing of elements that the earth performs constantly and without intention. But the earth that held it is still here, still turning, still making new things out of old materials. The experiment continues, in us and around us, in every seed that sprouts and every child that is born. We are not the end of the story, but a single chapter, one among many, and the chapters that came before are written in a language we are only beginning to learn to read. The night air grows still. Perhaps it does not matter whether we are the first or the second or the 10th attempt at life. What matters is that we are here, now, in this brief window of awareness, able to appreciate the improbability of our own existence. The question itself is a gift, a sign that the universe has produced something capable of wondering about itself. And in that wondering, there is a kind of grace, a quiet acknowledgement that we are part of something much larger than ourselves, something that began long before us and will continue long after we are gone, in forms we cannot imagine. We belong to the earth, and the earth belongs to time, and time belongs to no one. But for this moment, we are here, carrying the memory of all that came before, holding space for all that is yet to come. The past is not lost, only transformed, and we are its transformation, its latest expression, its ongoing question, whispered into the darkness and waiting for an answer that may never arrive, but somehow does not need to. The stars emerge slowly, as they have for billions of years, indifferent to the small blue world that circles one of their number. The same light that witnessed the first stirrings of chemistry in the ancient oceans now falls on sleeping cities, on quiet forests, on the slow rise and fall of tides that have never stopped moving. The world settles into its nightly rhythm, the cooling of air, the chorus of insects fading, the gradual dimming of all that was bright. The earth turns. Somewhere, deep beneath the surface, heat still rises from the planet's core, driving the slow dance of continents that has been going on since the beginning. Somewhere, in the darkness of the deep ocean, microbes cluster around vents that pour warmth into the cold, just as they may have clustered 4 billion years ago, when everything was new and the question of life was still unanswered. The processes that made us are still at work, still shaping, still creating, still waiting for whatever comes next in the long unfolding. The question fades. Whether we are the first or the second does not change what we are. We are the ones who are here, the ones who can lie in the dark and feel the weight of deep time pressing gently down, the ones who can close our eyes and imagine oceans that no longer exist, and life that may have flickered once before, falling silent. We are the continuation of something very old, and the beginning of something we cannot yet see, a link in a chain that stretches back to the first warmth and forward to whatever warmth may come. The darkness is soft now. In the quiet that settles over the world each night, the earth keeps its secrets, as it always has. The stone remembers what we have forgotten. The water carries traces of what we will never know. And somewhere in the silence, the ancient chemistry that made us continues its slow work, patient as only deep time can be, patient as the stars that watch and do not speak. The breath slows, and the earth keeps breathing. So do we.